All right, so hi everybody, I'm sitful-hatred. You might know me as Reed. And here I'm representing a company that me and 3 other guys have called Native Planet. And we make hardware and software for running urbits. There's 4 of us, and 2 of us are in Texas. The other guy in Texas, Dalek Bandler, he started this project and brought the rest of us on. And he is the guy who builds all of the beautiful machines that you've bought from us in his garage like an elf. And Mopful WinRux, who you might know, is in Georgia, and Alex Dosdrill is in Kuala Lumpur. We also have an industrial designer in Mexico who's responsible for those cool cases. And we do everything on Urbit. We run the company in a group chat. Hang on a sec. And we first started working together, the first 3 of us, last year in February or so. And then Alex joined us about a year ago. And despite starting a hardware company in the middle of a chip shortage, we actually started shipping devices in May. So today my presentation is basically kind of a broad overview of what we do, and why we do it, and what we're hoping to do in the future, and what we've been doing since last year. So Reassembly is special for Native Planet because this is where we announced our project to the world. Those of you who were here last year, thank you for watching me present that and for presenting this. So we're the Urbit ecosystem's first hardware company, and we sell home servers that run in your house like an appliance, like a toaster. You can just plug it in and kind of ignore it. We have kind of a simple setup process that's sort of akin to a Chromecast, where you plug it in, connect to a Wi-Fi network, go through a simple couple of steps, and after that, it lets you boot chips in a nice GUI menu. It connects them to the internet and makes them accessible, from your phone or whatever. And we do this with software called GroundSeg, which is the software that we've written explicitly for running urbits. In technical terms, it's a purpose-built container orchestration system that we designed for running Urbit. And the tagline that we have for it is that it's the best way to run an Urbit chip. So all of the features that we developed for it are kind of towards that end. So we have stuff like just automated S3 hosting locally on device that's accessible on the internet with one click. If we have the ability to control the device that GroundSeg is running on, importing and exporting peers, scheduling packet melds from outside of Urbit, and we have, obviously a nice GUI menu that kind of makes it a little more user-friendly for people who are new to Urbit, or people who just don't want to spend time in the command line. It's also open source, so you don't have to buy a device from us. You can just download it and install it on a spare PC. Sorry, I know there's not a picture here. I should probably just go back to the actual device. Let's see. So we also have an important feature integrated into GroundSeg called StarTram, which is what I spoke about at length last year. So this is the kind of custom networking backend that we built for GroundSeg, built on WireGuard. This is for forwarding your connection from your GroundSeg box to the internet. And on the other side of that connection, we have a reverse proxy that automatically configures, and it just serves your Urbit over TLS. That server also forwards AIMS packets back across the WireGuard tunnel. So it's basically transporting your connection, to this publicly accessible server while you retain the actual Urbit, in your house. So GroundSeg makes running chips easy, and StarTram lets you access them from your phone while you're out of the house. And it's designed from the premise that setting up a command line app with a TLS reverse proxy and managing port forwarding is a non-starter for pretty much everybody who's not already an IT professional or very interested in this as a hobby. So there needs to be an easy way to do this stuff, and that's what we tried to do. We've reduced the complexity of this process to entering one password one time, and that's it. So we've created this stack for our devices to provide a technical solution to the problem of hosted versus self-hosted chips. Having a hosted chip is nice because you don't have to worry about running it or managing a process on a Linux server. But having a self-hosted chip is good because you get to control everything. You can possess data physically. So why can't you have both? And you can. So last year I mostly talked about the design of StarTram and the kind of overall value prop. And today I'm going to talk more about the big picture and how we see ourselves, along with what we've been working on since last year and where, towards what end. All right. So in the year or so that we've all been working together, we've kind of developed a set of principles that act like a coordination mechanism for the design decisions that we make. This isn't like explicated anywhere. This is just like me kind of summarizing conversations that we've had in our calls every week, and like what decision or what factors into the decisions that we make, and like what are the things that are axiomatically good for us. So these are ideas that we think are cool, and we want the things that we make to be cool, so we want to use these ideas to shape the things. So this is kind of what I've arrived at as a summary. So obviously, all of us have a gut feeling that self-hosting is the right way to do stuff. So what's the point of having a personal server if you're running it on somebody else's computer? That means custody of your data, and on Urbit, that means running your own peer. So our hardware is meant to be a home appliance for running peers. Our networking backend allows you to run it at home without sacrificing ease of access or worrying about like your networking environment at home or like how anything works. So all this is to say that your data belongs at your house, and we want to mitigate the complexity that introduces by solving the problems for you ahead of time. Ownership of your data needs to be as easy as any other option. We're also ideologically committed to open source software, and this is like table stakes for us. Everything we do is on our GitHub. It's permissively licensed. It's, I think, all MIT. And if I'm running a server at my house, it's not going to be a proprietary server. Especially if it's handling stuff like communication, I want to know what I'm running. I'll highlight that there's one exception here, which is our in-house managed version of StarTram. So we have an open source version of this that anybody can download and run on a VPS. They can look at the source code. The only distinction here is that the managed version, the version that we run, is like for running many instances or it's a multiple tenant instance basically. And the open source version is like for running yourself. But I mean, under the hood, they work the same, and they have feature parity. So we're also open to feature suggestions and pull requests. And I think Little Wolfer so far is the only person who's taken us up on this. But if you have any good ideas, please let us know. Also, you probably will not be surprised to discover that a bunch of guys running an Urbit company are true believers. So we're Urbit maximalists. Urbit has a lot of rough edges that need to be smoothed out, though. So we see our role as edge smoothers in the service of onboarding. There's still a long way to go between now and Noct being the only legal form of computation, but we want to help figure out what gets it there, whether that's personal servers or some other value proposition that we all stumble upon. But I think it's clear that we have a dog in this fight and a predisposition toward the former. We also spend a lot of time talking about other ways to run Urbit. We've had a lot of conversations about what it would take to have first-class mobile Urbit, running it in other form factors, and especially IoT. And we have a lot of active lines of development, towards that last one especially, made possible by Lick, which I'll talk about a little bit, I'll talk about in a moment. And I would say the last principle is easy mode. It's the guiding principle of our design that we have kind of a default path that requires as little thought as possible. If you don't know how any of this stuff works, you should be able to basically just click next until it does work. So where complexity is unavoidable, we try to establish sane defaults and hide stuff in the advanced settings to avoid host scaring. If you have a problem with anything, our bug report button will usually get you the kind of customer service that doesn't scale and won't in the future. Under most circumstances, one or more of us will start looking at your issue as soon as it comes in. And at this point, we've resolved most of the major classes of bugs. So they don't really come in as much as they once did. So there's usually a single particular thing that people want out of running a ship, which is to turn it on and access it from anywhere on their phone or their browser, and basically forget about it after that. So we have sane defaults that are meant to minimize the friction for this path. As long as we're relying on S3 for external media storage, asking people to set up and configure it themselves will also be a tall order, since most normal humans have no idea what S3 is or why you would use it. To that point, most people never touch a command line in their life. And third-party hosting is the traditional answer to these questions of complexity, but we think that there is also another answer. All right, so this is our hardware. If you haven't seen it before, you'll notice that two of these are actually new, not for sale yet. The one in the middle is the Aurora, and the one on the left is the Tellurian 2, and the one on the right we call the Orbiter. which I'll speak about in a moment. So the Tellurian, which is not on this, but looks very much like the one on the left, was our first device. It has a custom aluminum enclosure with an exposed board and recycled PC components. It does a very good job of running like many ships. I mean, we've booted like 10 moons on one of them and didn't have any issues. We weren't like using them heavily or anything, but like they ran with like 8 gigs of memory. And they had 2 M2 NVMe drives and a hardware RAID 1 adapter. This was the solution that we came up with for like data integrity. It's kind of a hard problem because the peer is constantly appending and it's really, really big. So how do you make sure that you still have a copy of it? So we decided 2 hard drives is probably the way to do it. If you're familiar with the design firm Teenage Engineering, you can probably tell that we're also fans of them and we take inspiration from their visual style. And my favorite part though is that these have like a really thick chassis. Like they're heavy. The pictures don't do it justice, but if you pick it up, it's like 8 pounds. And it feels like a sculpture. So the Aurora, the one in the middle here, is it's our premium device that we made in collaboration with Purism, which is a hardware company that focuses on privacy. They're American. So this is like kind of like the Lambo to the Tellurian Civic. You can get it upgraded you can upgrade it a lot. The base model is very fast, but you can add on a lot more memory, disk space, and processor speed. I'm told that it also has an admirable heft, although I have not held it myself. But if there's one thing I'd like to impress upon you, it's that our hardware is extraordinarily dense and suitable for many self-defense purposes. So to elaborate on the car metaphor, we're also excited to release our tiny Japanese pickup, the Orbiter. So if you're in our public group, you might have seen some renders of this. We're trying to launch these at the end of the year. And you might notice, I guess it's hard on the TV, but they're very small. So these are x86-64 SoCs, but I mean they're like this big. They're like kind of like pie size, maybe a little bit bigger. And spec-wise, they're comparable to the original Tellurians, but with less memory. But importantly, they're much cheaper. They're like half the price of the Tellurian, and they're also like very light on power. So we haven't tried this yet, but you should be able to just like run it off of a USB power bank. So if anybody, I would encourage somebody to do that and to get like a USB LTE modem and try to like drive around and see if StarTram still works. So the neat part about shipping these is that like most of the work we do is transferable between devices. So there's not a lot of difference between x64 boards and running on Linux, which handles a lot of abstracting away the differences. So we get to spend all of our effort on improving the software and making sure that the enclosures are charming. So we should have, I think, like a dozen of these to give away and at assembly. So if you have a good idea for the hackathon, you might get one. And also, I mentioned they're called the Orbiter. All of us are kind of like not super into that name, so please come up with a better one and tell it to me. All right, our software that I mentioned, GroundSeg, is an urbit ship orchestration agent that has a lot of purpose-built bells and whistles for managing ships. And it's meant to run on a dedicated device, but it doesn't have to be one of ours. Our installation script should work on most Linux systems, assuming that I think you have to have like glibc 2.31 and systemd, which is like most Debian-derived systems. So we have like an install script on our website that you can just run, like paste into your command line because you trust us, and it'll download a binary and run it as root. And that's why we want you to run this on a dedicated device, because we have to manage the hardware. GroundSeg version 2, which you see here, is a major design overhaul. So we tried to take inspiration from Winamp 3 in the visual style. That was one of our points of reference. It's also got some changes under the hood in the back end that I guess version 1 the speed is not always what we wanted it to be, so we've redesigned how some of it works, and it should be a lot snappier, and it should be released around, right, or by assembly is what our deadline is. So I guess, under the hood, the kind of main difference is that we're switching from kind of a conventional REST API to WebSockets, and there's a lot of other redesigned stuff that facilitates the new interface. Alex Dosriel is our lead GroundSeg dev. That's the guy I mentioned, Kuala Lumpur, and he's been hacking away at this for the last few months. I'd like to give a shout out to him because he's a very talented developer. It's delivered a lot of wins for us in between teaching us cultural lessons about Southeast Asia. So probably the most exciting part of the V2 release is that we're planning to release a new urbit app alongside it, and internally we call this GroundSeg. Also a bad name. Please come up with a better one for us. We'll probably think of something before release, but since early on we've wanted to be able to control GroundSeg from inside of urbit. There were various technical obstacles that made this harder than it sounds. But Mopful WinRux, the fellow in Georgia, has worked on a kernel vein called lick that made this a lot more tractable. So the upshot of this is that soon we'll be able to control the host device from inside urbit, like through an app served through urbit's web server, even remotely. So this GroundSeg app will allow you to boot and control other ships on your device from within your ship. So this also opens up the possibility of things like a self-hosted Lure equivalent. I should say this is opening the possibility. I'm not promising anything. One thing that is worth bearing in mind, though, is that you can control the device that your ship is running on, which I don't think anybody has done with urbit before, which is pretty cool. I think you can actually manage the host. So this is an exciting frontier in Earth-Mars communication. This also is groundwork for deeper and perhaps device or peripheral specific integrations in the future. StarTram, like I mentioned earlier, is the networking backend. So this is mostly used for giving you a public web interface, but it also forwards AIMS packets, and it's kind of generalizable to just like network traffic of any kind. So we think of our boxes as home servers in the general sense. But our plans remain oriented around urbit functionality, and right now we're working on home-hosted WebRTC using the same kind of backend as StarTram uses now, and it should be as easy as the S3 buckets. Although there's limitations. I think the main throttle would be like how much you can actually stream back to your home connection, right? So that might end up being the bottleneck. We've also started some tentative work on moving some of our CI/CD infrastructure into urbit. This probably sounds more impressive than it actually is, but basically like GroundSeg checks a version server for just finding out what the current version of its components is and updating them if they're not current. And so what I'm trying to do is replace this just HTTP GET request for a JSON blob. I'd like it to be a remote scry, and whenever we push a release, I'd like to update the state of this of I guess probably a moon of our star, and then just have everyone's GroundSeg check that. I'm not sure if this is like realistic. It might DDoS it or something, but we'll see. So aesthetically, I think there's something to be said for trying to swallow what we can from Earth. This is very much to the point that Little Wolfer was making yesterday. We kind of have to accept the world as it is. A lot of the world is not pure Martian software, and we have to meet it somewhere in the middle. All right. So our CTO, Mopful WinRux, has been busy contributing to urbit core development. That's especially useful for us because he's had a close eye on new development and gives us time to prepare for changes or adapt to new features. But he's also a very skilled engineer, and he has a lot of feathers in his cap. One of those feathers is called lick. This is, as I mentioned, this is a vein, a kernel module for hardware control from within urbit. So this basically allows you to use Unix IPC from urbit, so you can communicate with stuff outside of your ship from inside of it. I think this is the first vein that was written by a non-core dev. This is for an Urbit Foundation grant, and it was completed, I think maybe like a month or two ago, and it should go out with the next binary release, which I think is in a week. You might have seen that he posted a demo on Twitter, which was him printing on a thermal printer from inside of his ship. It was, I think, a blimp down message. And he also took one of Mark made a snake game, and he made an Earthside UI that was driven from Mars. So this suggests to me that maybe there's something with driving peripheral like displays or something that we could do here. Like I mentioned, it makes it possible for us to write urbit software that crosses the hermetic seal and manages computers, or conventional computers. And this is the kind of thing that we want to do in the future. We want as many devices as possible to run urbit, or at least be managed by devices that do. Mottful has also been contributing to Lagoon and Saloon with Neil, and those are the libraries for linear algebra and matrix multiplication. So this is the groundwork for any future that urbit has with machine learning. This is what it's going to be built on. So obviously we're also interested in accommodating that, although it's still very early days. And here's probably the most exciting thing I'm going to tell you today. This is the Reassembly23 exclusive announcement. Those of you who know Mottful WinRux probably know him as the guy behind the NockPU project. This is the first serious attempt to design a computer meant to execute the Nock ISA directly rather than virtualizing it, which is what we do when we run Ver. This is how I came to know who he was anyway, and this is why I wanted him on the Native Planet project. And our generous host, Jay of Tacen, has agreed to fund a research grant to complete the NockPU project. So this is a long-term project that is going to basically be his main focus until it is completed. So this is implementing Nock in Verilog and then programming an FPGA with it, which will be delivered on a little pillow to Jay, who will be the only person who owns one. And although he wants to impress upon, or Mottful wants me to impress upon you that the end of this project is not a consumer product. This is a research project. This is as much to do the thing as it is to figure out what problems there are with it and whether it's even worth pursuing, in the first place. It might turn out that an embedded interpreter is just inherently more efficient, and that at least this is why we're doing it, to find out what's possible and what we should be doing. So this kind of work is not easy. Mottful has. Right now he has a day job. He works, in Native Planet work, and he contributes to Urbit Core. So it's been slow progress until now, but hopefully this will allow him to focus his efforts. And if anybody on the network is capable of doing this, then Mottful is the guy. So I'm very excited about this. That's our stable diffusion mascot. That's Native Planet Chan.
So you talk about LIC, and then I saw one of your devices had USB ports. Mm-hmm. That excites me in the way I get excited about Raspberry Pis. What are the plans for the USB ports?
Well, so I should say, these are prefab x64 boards. We didn't put the USB ports there, but in the future we will definitely be aiming to take advantage of peripherals with LIC. That's the big reason that Mottful did this.
Cool.
Do you guys have any plans for having Native Planets work at a city scale mesh network?
So we have some tentative plans for daisy chaining on a LAN, which I think would be probably a similar kind of thing. And this has been a back burner item because it has mainly we started thinking about this because we were like, what if we had two of these on the same LAN and they have the same host name? How do we figure out if there's already one of these on the network, and what do we do if there is? And the solution we came up to is kind of like a daisy chaining thing where there's kind of a master server. But if anything like that comes out of what we do, I would think it would probably come from the development of that line of thought.
There's a question there. I know you said that you're going to have some orbiters or whatever their future name is at Assembly for prizes. Do you have like an estimate on like what you think the lower cost you might be able to hit is, and when like you think they might be available for people to buy?
So our target sale time is I think like December, and the price is, I can't like promise a number, but they told me that if somebody asked, I could say $250. Yeah.
Any other questions? I'm sorry.
Are you guys thinking of making like a one of these as small as like the Urbit cube, or is that just not possible?
So the Urbit cube was like, I found the board that they used, and it was like an embedded router, like like ARM board. I mean, it was. I guess it was technically capable of running Urbit, but I don't know if it would provide the experience that we. I mean, maybe in the future, as you know, as things get faster and smaller, this will be possible. But at least what we're looking at now, I think probably the Orbiter is the smallest form factor we're going for, you know, for the time being.
Okay. And another question: do you use Lick just for the hardware stuff, or do you use it for like the hosting management stuff?
So, I think we would be using it for the hosting management stuff. The CI/CD stuff I mentioned earlier would be taking advantage of that.
Cool.
But this is also tentative. This isn't something that I have actually like finished or started using. So this is like just a thing I've been pursuing.
Okay.
So I very much agree with the ethos Native Planet has, that, you know, a personal device for your personal server. How is Native Planet thinking about things like small groups of people wanting to compute together, having like, let's call it like a small family group where, you know, I'm the admin, right? But I've got to coordinate all of these people together, and when something breaks, it's really my problem. But I need to be able to. How's Native Planet thinking about small hosting environments or boutique hosting environments?
So one of the things that we have kind of as a back burner item is kind of delegating a ship or a set of ships as kind of administrators that are able to manage this is really just kind of revoking permissions for other users. Like right now, you know, if you have a user account on your Native Planet, you're the root controller of everything. But we would want to create kind of a tiered system where there's like users and administrators, and then once we have GroundSeg, you know, out there, and you can manage this remotely, you know, it makes it much easier for like one person who's running a ship on a device to kind of manage the other people's ship, like their friendships, and boot them for their friends, and, you know, restart them or whatever.
Can you speak a little bit to the upgradability of your devices? Like if I buy one of your units right now, but I want to expand the hard drives later, for example, is that possible with all of these or some of these?
Yeah, okay, so I can say it's definitely possible with its Tellurian. I don't have direct experience with the Orbiter yet. I think there's like one demo unit that Austin has, Dalhik Bandler, and I'm pretty sure you can upgrade all of them, except I'm not positive about the Orbiter. But yeah, I mean they're not like, you know, they don't have like soldered memory or anything like that.
Okay. Any other questions? All right, then. Well, give it up for Sitful.
Thank you.